Welcome back. Now we're doing another section, questions 101 through 120 of the AWS Machine Learning Associate Exam. Before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning exam. 101, company needs an AWS solution that will automatically create versions of ML models as the models are created. What solution will meet this requirement? Okay, Model Registry. This automatically versions models when registered. It tracks model metadata, artifacts, and lineage. It supports approval workflows for production deployment. It integrates with SageMaker training and deployment. It's purpose-built for machine learning model versioning and provides model governance capabilities. The registry features include automatic version incrementing, approval status tracking, model metadata storage, and deployment tracking. Why are the other options incorrect? So ECR is a container registry, not machine learning specific model versioning. The marketplace is for purchasing third-party models, not versioning your models. And lineage tracking is for tracking relationships. Model registry handles versioning. 102. Company needs to use a RAG to supplement an open source language model that runs on Bedrock. The company's data for RAG is a set of documents in an S3. The documents consist of CSV and docx files. What solution will meet these requirements with the least operational overhead? Create a pipeline, convert the data into vectors, stored in Neptune, fine-tune an LLM using AutoML, or create a knowledge base for Bedrock. So Bedrock knowledge base is purpose-built for RAG. It automatically ingests and processes CSVs and docx files, handles chunking and vectorization automatically, manages vector storage internally with OpenSearch serverless. It directly integrates with Bedrock LLMs and is the least operational overhead, and is fully managed. So how would you do this? You'd point the knowledge base to the S3. Bedrock would process the documents automatically. The query would be via the Bedrock API. The LLM would augment with retrieved context. Why are the other options wrong? So SageMaker pipelines create a new model, not RAG supplementation. Neptune manual vectors require manual vectorization and management, and fine-tuning changes the model itself, not the RAG approach. 103, company plans to deploy an ML model for production inference on SageMaker endpoint. The average inference payload size will vary from 100 to 300 megabytes. Inference requests must be processed in 60 minutes or less. Which SageMaker inference option will meet these requirements? Serverless, async, real-time, or batch? B, asynchronous supports payloads up to 1 gigabyte, supports processing time up to 15 minutes. It's queue-based architecture using SQS for durability. It autoscales based on queue depth. It's cost-effective for large payloads and built-in retries and DEL queues. So the payload limits for serverless would be 4 megabytes. For real-time, it's 6 megabytes. Asynchronous is 1 gigabyte. And batch has no real limit. It's S3 based. So why are the other options wrong? We just spoke about that. Serverless and real-time have too low payload limits. And batch transform is for offline processing, not individual endpoint requests. 104, an engineer noticed a class imbalance in an image classification training job. What should the engineer do to resolve the issue? Reduce the size, transform the images, apply random oversampling, apply data splitting. C, random oversampling duplicates minority class examples. Balances class distribution for training. It prevents model bias toward majority class. It has a standard technique for addressing class imbalances and can be combined with data augmentation. So the example would show before this, class A would have 1,000 images, class B 100 images. After oversampling, class A would have 1,000 images, class B would have 1,000 duplicated. The model sees the balanced representation. Why are the others wrong? A reduced data set would make the imbalance worse. You would lose valuable data. Transforming images, this data augmentation would help, but not directly address the issue. And random splitting would maintain the existing imbalance ratio. 105. A company stores customer transaction data in a CSV in an S3. The data contains personally identifiable information, including credit card numbers. The company needs to identify and mask PII before using the data for ML training. What solution will meet this requirement? Macy, Comprehend, Glue, Data Wrangler. Data Wrangler has built-in PII detection. Redaction operators mask PII directly in the workflow. The visual interface is for data preparation. There's no custom code. It integrates with SageMaker training pipelines, and you can preview the results before applying. It'll detect credit cards, social security, emails, phone numbers, and it'll redact it with tokens or hash values. And it has built-in regex for common PII types. So Macy is wrong because it's a discovery service. So that's a separate task altogether. Comprehend because it detects entities, but requires custom code. And Glue could work, but requires more custom code. So Data Wrangler is your option. 106, an engineer is building a fraud detection system. The cost of missing fraud, like false negatives, is much higher than the cost of false alarms, false positive. Which approach should the engineer take? Answer is B, high recall. So this measures the ability to catch all fraud with that formula. The high recall minimizes false negatives, and then it's acceptable to have more false positives because they can be reviewed, but the cost of missing fraud is greater than the cost of investigating false alarms. So the fraud detection prioritizes catching all fraud cases. So the impact, missed fraud means major financial loss. A false alarm means a manual review. So you need to maximize recall, excuse me. Other options are wrong because precision minimizes false positives, but increases false negatives. F1 doesn't prioritize the more costly error. It tries for balance. Accuracy is misleading with imbalanced data. 107, company wants to implement continuous model retraining when model performance degrades. The solution should automatically detect degradation and trigger retraining. Which combinations of services achieves this? SageMaker Model Monitor, CloudWatch Logs, Event Bridge, Lambda, S3 Lifecycle. A and C, Model Monitor and Event Bridge. So Model Monitor continuously monitors model quality. It detects model performance degradation. It compares predictions against ground truth. It generates CloudWatch metrics when cloud quality drops. It's purpose-built for ML Model Monitor. Event Bridge listens for Model Monitor quality alerts. It triggers a SageMaker pipeline for retraining. It's an event-driven automation with low operational overhead and can orchestrate a retraining workflow. You see the architecture there, how it all links together. So why are the other options incorrect? CloudWatch Logs is storage only. It doesn't detect degradation. Lambda is manual, and it's not continuous. And S3 is for data management, not retraining triggers. Question 108. A gaming company is building a recommendation system for in-game purchases using SageMaker. The company wants to minimize the cold start problem for new users who have limited interaction history. What approach will best address this? Collaborative filtering, hybrid recommendations, increase the training dataset size, or use only content-based filtering. Hybrid systems leverage both user behavior and item features. So content-based filtering works for new users with no history. It uses item features like the genre, price, and category for initial recommendations. And the collaborative filtering will improve as interactions data accumulates, provides recommendations even with sparse data, and it's a best practice for cold start problems. The hybrid approach has a new user with content-based, so item similarity, and after interactions has a collaborative filtering for user similarity. So it's the best of both worlds. So why are the other options wrong? So collaborative only fails completely for users with no history. Duplicate data doesn't solve the cold start. It just creates overfitting. And content-based misses user preferences from collaborative data. 109. Financial services company needs to deploy a fraud detection model that makes real-time predictions. The model must provide explanations for each prediction to comply with the regulatory requirements. Which deployment approach should the company use? SageMaker Batch Transform, SageMaker Real-Time Endpoint with Clarify, SageMaker Serverless Inference, AWS Lambda. So, Real-Time Endpoint provides low latency predictions for fraud detection. SageMaker Clarify offers online explainability. It generates explanations for each prediction in real time, meets regulatory requirements. It's production ready, scalable solutions, and integrated monitoring and logging. So you can see an example output. So why the other answer is incorrect? Batch transform is not real time. Serverless without explainability doesn't meet the regulatory requirements. And Lambda is high development and overhead, so you're reinventing the wheel with custom code. 110. A healthcare company is training a medical image classification model using SageMaker. The training data is stored in S3 and contains PHI. The company must ensure that data remains encrypted at all times and that only authorized personnel can access it. Which combination of actions should the company take? Choose 3. Enables S3 SSE with KMS. Store it in S3 IA to reduce costs. Configure SageMaker to run in VPC mode. Use S3 object lock to prevent data mods. Implement IAM with least privilege. Enable S3 versioning. A, C, and E. So SSE with KMS, customer managed keys, provide granular access control, supports key rotation and audit logging via CloudTrail, which is required for HIPAA compliance, and encrypts PHI at rest in S3. VPC mode is network isolation, which protects the PHI in transit during training, prevents data exfiltration to the internet, required for HIPAA compliance, and uses VPC endpoints for S3 access. And then least privilege IAM restricts access to authorized personnel only, supports NIST 853 AC access control requirements. There's an audit trail via CloudTrail for all access, and it's essential for HIPAA compliance. So why are the other ones incorrect? So standard IA is just a storage class, doesn't affect security. Object lock is for compliance retention, not encryption or access control. And versioning is for data recovery, not security requirements. 111, Silicon Valley startup has introduced a new email service that would completely eradicate spam from the inbox. The data scientists at the startup have prepared the following confusion matrix for the underlying model. Here's the confusion matrix with the true positives at 8,000, false positives at 2,000, false negatives at 1,000, true negatives at not shown. What's the F1 score for the underlying model? Huh. So it's true positives divided by true positive plus false positives. So calculated precision, which would show true positive divided by true positive plus false positive, that 8,000 plus 2,000 equals 0.8. Calculate the recall. So it would be true positives divided by true positives plus false negatives. So it would be 8,000 plus 1,000 divided, or 8,000 divided by 8,000 plus 1,000. So 0.89. And then calculate the score would be 2 times the precision times the recall divided by precision plus the recall. So that would be 2 times 0.8 times 0.89 divided by 0.8 plus 0.89. Interesting. Okay. So it would be 1.42 divided by 1.69 to be about 0.84. So the F1 score is the mean of precision and recall. It provides a balanced measure between precision and recall. So it's a range between 0 and 1, with 1 being perfect. So, okay. So 0.63 would be too low. 0.93 would be too high. And 0.73 would be too low. And neither of them match that score. So it looks like, that true positive to true negative, true positive, false negative, and you can get between those two, you would be pretty close or round it. Yep. Anyways, 112. A medical diagnostics company specializes in cancer detection tests. The data scientists at the company are working on a classification model to detect cancer, and they do not want any cases of cancer going undetected. The classification model's predicted value of 1 implies that the patient is predicted to have cancer, which is the following metric should the data scientists focus on so they can achieve desired objectives. Recall, F1 score, accuracy, precision. Recall. So recall measures the fraction of actual positives correctly identified. So that formula would be true positive divided by true positive plus false negative. So it minimizes the false negatives, so the missing cancer cases. The high recall ensures patients with cancer are not incorrectly classified as healthy. So medical diagnostics for serious conditions, maximizing recall is critical. And it's better to have false positives with unnecessary follow-up than false negatives, meaning missed cancer. So false negatives would mean missed cancer diagnosis. That's unacceptable. And a false positive means additional screening. So don't miss any cancer cases would be the priority. Why are the other options wrong? F1 would balance that precision and recall, but recall should be prioritized. Okay, accuracy would measure overall correctness, but doesn't focus on minimizing false negatives. And precision would focus on reducing false positives, not false negatives. Okay. So 113. How many shards would a Kinesis data stream application need if the average record size is 500 kilobytes and 2 records per second are being written to this application that has 7 consumers? C. So 1 megabyte per second or 1,000 records per second for write. Read is 2 megabytes per second per shard, so it aggregates across all consumers. So you calculate the incoming bandwidth, right? Incoming would be record size multiplied by records per second. So it would be 500 kilobytes times 2 would be 1,000 kilobytes per second. Then calculate the outgoing read bandwidth would be incoming times number of consumers would be 1,000 kilobytes times 7. So it'd be 7 kilobytes per second. Then calculate the required shards. So you have 1,000 kilobyte for write. Shards for write would be 1,000 kilobytes per shard would be 1 shard. Shards for read would be 7,000 kilobytes divided by 2,000 kilobytes per shard. So that would be 3.5 to 4 shards. So you round up. So the required shards, the max 1.4 would be 4 shards. Why are the other options wrong? So 7, 1 shard per consumer is not the formula. 3, this would exceed the read capacity. So 3 times 2 megabytes equals 6 megabytes, which is less than the 7 megabytes needed. And 1 would be insufficient for the 2 megabyte per second read bandwidth. 114, you're analyzing the salary trends for Silicon Valley engineers over the last decade. The data set has information on the age, professional experience in years, skill level from 1 to 10, gender, location, 5 distinct locations, and salary. What's the best way to visualize an average annual salary trend at each location over the last decade? A line chart with location as different colored lines and years on the x-axis, a scatter plot with salary on the y-axis, and years on the x-axis, a bar chart comparing locations, and a heat map with locations and years. A. So the line chart would show the trends over time effectively with multiple lines, 1 per location for easy comparison. The x-axis is years, y-axis is salary, and you have color-coded lines to distinguish the locations and clear visualization of salary growth trends per location, which would be easy to identify which locations have the highest or lowest growth. So this would show time series progression clearly, location comparison at any point, trend patterns would be identifiable, and it would be standard for temporal trend analysis. Why are the other options wrong? So a scatter plot would show individual data points, not aggregated trends by location. A bar chart would be better for categorical comparison, not temporal trends. And a heat map could work, but it's less intuitive for trend visualization than a line chart. 115. The company is using a pre-trained ResNet 50 model for image classification. The company has a data set of 500 images per class for 10 different classes, 5,000 images total. The company wants to adapt the model for this specific use case. Which approach would yield the best results with the data set size? Train the entire ResNet model, use transfer learning, use the pre-trained model, train only the first few layers and freeze. So transfer learning. This uses pre-trained features from ImageNet. 5,000 images is insufficient to train ResNet from scratch, so you need 100,000 plus. Freezing convolutional base preserves learned feature extraction. Training only the final layers adapts the model to specific classes, prevents overfitting with limited data, is much faster than training time, and is an industry best practice for limited data sets. So how would you do the transfer learning? You load the pre-trained ResNet 50, freeze all convolutional layers, replace the final classification layer with 10 classes, train only the new classification layer, and fine-tune the top layers. Why are the other options wrong? Train from scratch, 5,000 images is too small. It would be way overfit. No modifications. This won't work for different number of classes. And training the first layers. So early layers learn generic features and should be frozen. 116. A model for document classification uses word embeddings. The vocabulary size is 50,000 words. The company wants to reduce the dimensionality of the embeddings while preserving semantic relationships. Which technique should be used? PCA, TSNE, autoencoders, feature hashing. PCA reduces dimensionality while preserving variance. Linear transformation maintains semantic relationships. Computational for large vocabularies like 50,000 words, retains most important information in fewer dimensions, and it can reduce from 300D to 50D while keeping 90% of the variance. It's standard for technique for embedding dimensionality reduction. What are the PCA benefits? There's fast computation, deterministic results, preserves the global structure, and it's easy to interpret the principal components. So why are the other options wrong? So TS&E is for visualization, so 2D or 3D, not dimensionality reduction or modeling. Autoencoders, this can work for computationally, it can work, but it's computationally expensive compared to PCA. Feature hashing can reduce features but doesn't preserve semantic relationships. 117. A retail company uses a customer service chatbot powered by an LLM through Bedrock to handle product inquiries and returns. Customers have reported that the chatbot gives slightly different answers when asked the same questions about return policies or product details. The company needs to ensure the chatbot provides consistent responses. What solution will solve this? Adjust the temperature parameter to a higher value and increase the top K. Retrain the LLM with retail-specific data. Enable caching in the chatbot. Adjust the temperature to lower value and decrease the top K parameter. D. Temperature parameter controls the randomness in the token selection. The lower temperature produces more deterministic consistent outputs. Top K limits the token sampling to K most likely tokens. So lower top K, 10 to 50, will restrict the choices, increasing the consistency. So both adjustments will reduce the variability. There's no training required. This will be an immediate implementation. So you can see the temperature settings, 0.0 to 0.2, or a top K of 10 to 20. Very deterministic with limited token choices. Why the other options are wrong. So higher temperature in top K would increase the randomness and variability. It would make the problem worse. Retraining would be expensive, unnecessary, because the parameters solve the issue. And caching would only help for exact same queries, not similar ones. 118. Companies deployed multiple ML models and needs to perform A/B testing to compare model performance in production. The company wants to route 90% of the traffic to the current model and 10% to the new model. Which SageMaker feature should be used? Multimodal endpoints, production variants, shadow deployments, batch transform jobs. B. So production variants allow multiple model versions on the same endpoint. Traffic distribution is configurable with per variant, 90%, 10%, 10% is covered. There's real-time A/B testing in production. You can monitor performance metrics per variant. There's gradual rollout capability, so canary deployment. And you can adjust the weights dynamically without redeployment. And so you can see a configuration example below. Why are the other options wrong? So multi-model is for hosting many models efficiently, not A/B testing. Shadow deployment is for testing only, doesn't serve the production issue. Batch transformation is for offline batch processing, not real-time A/B testing. 119. An engineer needs to process a dataset with missing values. Some features have 5% missing, others have 40% missing. The engineer needs to handle these appropriately. What's the best approach? Drop all rows with missing values, drop features with 30% missing, impute with 30% less than 30% missing, impute all missing values with zeros, use forward fill for all missing values. Okay, B. So 40% missing is too much to reliably impute, so you have to drop that feature. 5% missing can be effectively imputed without bias. So the threshold of 30% is an industry standard. This will preserve data while maintaining quality. The mean and median imputation works well for numerical features, so now you can balance data retention and quality. So missing data structure. If it's less than 10% missing, impute it. Use the mean, median mode. If it's 10 to 30% missing, impute it with caution or advanced methods. And if it's 30% more missing, consider dropping the feature. So that context matters, so some domains might tolerate more. Why other options are wrong? Drop all rows, you would lose too much data, potentially 40% of the data set. Zeros would introduce a bias, and zero might not be meaningful. Forward fill would only be appropriate for time series data. Question 120. A company wants to detect fraudulent transactions in real time. The fraud patterns change frequently as fraudsters adapt. The current model's performance has degraded. What should be implemented to maintain model performance? Increase model complexity, implement continuous monitoring, collect more data, switch to a different algorithm. B. So fraud patterns evolve, requiring regular model updates. So continuous monitoring detects performance degradation. Automated retraining with recent data can capture new patterns. MLOps best practice would be for production machine learning systems, and this would address the root cause, changing data distribution. And this would maintain the model's relevance over time. So with the continuous model machine learning pipeline, you would monitor the model performance with Model Monitor. You would detect the degradation with CloudWatch alarms. You could trigger retraining with an event bridge to a SageMaker pipeline. You could validate the new model, deploy it if it's improved, and then repeat the whole process. Why are the other options wrong? More complexity does not address the changing patterns. More historical data, old patterns might not be relevant. A different algorithm would not solve the data drift problem. So thank you for joining. Before you go, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. Before then, have a good day. See you for the next one.